Everyone can hear me? Cool. You already saw a sneak peek of what to come. Actually, I'm on call, so I hope no page comes while I'm doing this. But thanks everyone for coming to the talk, and appreciate taking the time out at what 3:50. So today I'm going to be talking about automating fleet-wide cluster operations, basically, right? So, oh shit, no, not this. Yeah, I'm going to be talking about. I'm talking about bootstrapping hundreds of clusters. Yeah, sorry, across CSPs. So that was a superset of this presentation only. So what does that mean, right? At Kong, we have an offering called Dedicated Cloud Gateways. So before we get into that, right, this is the agenda today that we'll be following. What is Cloud Gateways? Basically, where we use or where we have gotten for this particular talk. What are the cluster components that we deploy? And what is the approach that we take, right? So one key component for the approach that we wanted to ensure for this product is it should ideally be self-managing and self-healing to basically ensure, because you have hundreds of clusters, right? Now, you don't want engineers or someone to actually interact with them and run them and make sure that they are running fine, right? So the idea is that we want to run an infrastructure which heals itself and manage itself. I mean, there's still cases, break glass scenarios, where you still have to go into the cluster and fix things. But most of the cases, it actually heals itself, right? So I'll explain how that works. So let's talk about what are cloud gateways. I hope everyone here knows what Kong is and what API gateways are. Yes? OK. I didn't hear a big cheers. OK, cool. So I won't go into what API gateways are, but what cloud gateways essentially are, that it's a SaaS offering where we actually host the API gateway that you run, right? So instead of you running your API gateway in your infrastructure and managing that, upgrading that, and making sure that it's always available, it's us who run that, and we make it available to you over private networking and stuff, right? Now, as you can imagine, because we run customer data and customer requests flow through that system, we have a very, very high requirement for separation of concerns, right? Because customer A will never allow, hey, in the same runtime, you can have multiple people going through, the request going to the same infrastructure. So, and a lot of compliance is also something that they require. So those also prohibit us from doing that. And that's why we run a bunch of these clusters. So every customer gets a cluster. You get a cluster, and you get a cluster, right? So because it's such a high volume of requests that flow, a lot of SLA requirements and costs, right? Cost is also another, because the more components we run, the more expensive this cluster is, the more runaway infrastructure that we have, the more cost is borne by the customer, right? So we want to ensure that is why we want it to be self-healing and self-managing in nature. So that is what Cloud Gateways is. We host your data planes, and that's where the traffic goes, right? And it's secure by default, and we comply with certain industry standards, like and PCI DSS is also coming soon for your fintech guys. Yeah, so let's jump straight into it, right? And it's a heavy slide. I'll explain what all of this is. So you have the left side of it and you have the right side of it, right? The left side where you see the central account, on the right side, which is the CSP account, right? I'm not going to be talking about the central account because that's not part of the scope of the topic, but that's another topic for another talk as well. Just the right side. So I just put the left side here just to show as to what are the components that are involved to ensure that a particular CSP cluster is created and ready, right? So everything on the left side just ensures that a cluster is created, ready, and in the state that we want it. When I say in the state we want it, that means the node pools are the correct type of node pools, and the control planes are right, the logging configuration is basically everything that when you create a cluster you configure, right? Those things are managed by the left side of things. And the right side is where the actual cluster gets created, and that's where the actual workloads run. right? Yeah, I'll just talk about that now. So what are some of the cluster components that we run? So if you see here, right, on the right side, you see augment services and Kong pods. So the Kong pods are actually what the customer's workloads are theoretically, right? Because we provide Kong as a service. That is the customer workloads. And the augment services are there to make it self-managing and self-healing in nature. So I'll talk about what those augment services are first, and then we're going to talk about how we get them out to every cluster that we create and delete and get rid of them during deletion flows, right? Deletions are rare because customer workloads are not ephemeral, they are long running. But yeah, during creation time, I'll talk about that at least. What are some of the cluster components that we run? So what we deploy, CSP to CSP differs, by the way, right? Because certain CSPs have a requirement to do certain things, whereas certain CSPs do not. So we run Flux CD. Flux is something we run to ensure Bootstrap, right? So these services that I was talking about, augment services, how do you deploy them? Instead of us running, from the left side from CentralCon actually imperatively creating these services, we use Flux CD and use the GitOps model, right? So what we do is we plant a seed, which is Flux CD, from the central account. So from the central account, we plant the seed, right? And then that seed automatically grows to a plant and deploys everything, right? So Flux CD is the key part of our infrastructure or our Bootstrap strategy. And don't ask me why we use Flux CD. I mean, there are multiple technical reasons, but one big reason is because one of the maintainers of Flux CD works at Kong. So we know what Flux CD is and how it works as well. Kong gateway operator, this is used so that the Kong pods that are running, they can be managed automatically. Again, how KGO works, that's another topic of talk. But just know this, Kong gateway operator is responsible for creating and managing and upgrading and all of the use cases related to Kong, right? Kube Prometheus stack. So there's a popular open source Helm chart that we use. So we deploy Prometheuses and alert managers within the clusters to ensure that what is happening to those services, what is happening to the pods, is constantly being monitored. The cluster state is being monitored. The alerts are being dispatched correctly to the right Slack channels, right PagerDuty. That's what I was alluding to, that I was on call. If something goes wrong, which our infrastructure cannot self-heal, then alert manager sends us a page or an alert, right? It also sends us some warning alerts as well. VM agent is basically Victoria metrics agent. This is what we use to collate all the metrics that are collected by Prometheus and send it to a centralized Victoria metrics storage so that we can put Grafana on top of it and actually observe. Because you cannot have like Grafanas installed with each and single cluster. That's just very, very problematic. So if you want to, for example, go look at, hey, how is Kong doing in that particular cluster, in that account, in that zone, right? It's very, very problematic. So VM agent is for that. Metrics exporters. So these metric exporters are basically to export cloud provider metrics as Prometheus metrics, so our Prometheus can take that, right? So for example, for CloudWatch, for Stackdriver, for Azure, right? We use these metric exporters so that they scrape these endpoints, the Stackdriver and stuff, and exposes that to Prometheus. Carpenter. In case of AWS, we use Carpenter for cluster autoscaling. And in case of GCP and Azure, we use the native autoscalers because Carpenter for Azure at the time was not GA, and for GCP it's just not implemented as well. We want something here which is cloud agnostic, and we are actively looking for something which can replace or actually do what Carpenter does for AWS across cloud providers, right? Because it's a multi-dimensional autoscaler. AWS LB control, again, this is an AKS specific thing. In GKE and Azure, I think they have their own controllers which is not exposed to us. So this is used so that the Kong pods that we are creating in those clusters, they can be exposed to the internet via an LB, right? So the entire life cycle will be managed by this particular controller. And then log scrapers, so that all the logs from the clusters, different components that we run can be shipped to a central place. Yeah, I mean, this is also required for a lot of compliance as well. So these are the things that we run. Now let's talk about how we bootstrap, right? What is the actual process? So this is the architecture for how it actually works. So on the left side, there's a foundational infra controller, which is what runs in the central account. What it does is, we have a Bootstrap repo. It's a GitHub repo which contains all the relevant Helm charts for all the augment services that I was talking about. And what this foundational infra controller does is it deploys the Flux CD. So it plants the seed, and it says to the seed that, hey, look to this particular repo, right? And this repo contains all the configuration that we want, right? This particular repo follows a very, very strict pull request review, linting, and all of the things that we want, because this is the source of truth for all the clusters. If this gets corrupted, then all the clusters, we have mirrors and stuff to ensure that it doesn't get rolled out to all the clusters if a bad config gets pushed. We have some safeguards in place, but this is the source of truth, right? Where we hold all of our Helm charts, all of our customizations and stuff. The foundation infra controller plants the seed, and it applies a root customization to the root of this repo, right? I'll show what this repo structure looks like as well. And then what Flux CD does is it reads all these Helm releases as referenced by the root customization. So that root customization refers to different folders depending on which cloud provider it is, right? Because we cannot apply the same things across cloud providers. So that root customization has the path that in this repo, inside the AWS folder, you'll find all the Helm charts for AWS, right? In GCP, you'll find all the Helm charts for GCP. And then the Flux CD has 3 components: Helm controller, customized controller, and I think source controller, yeah. So the Helm controller will then see, okay, these are Helm release objects. I need to reconcile them, right? And it does drift detection and everything. And this Flux CD consistently keeps a track on this particular repo, right? So anytime something changes, it automatically pushes changes out. And if something changes in the cluster which you don't want, then Flux CD will switch it back, right? That's the self-healing part of it. And self-managing part is that everything is here. Now everything is being managed automatically by Flux CD. This becomes our brain. This becomes our thing. So our foundational infra controller ensures that Flux CD is always in the correct state, right? And this foundational infra controller, by the way, is a reconciler. It's an operator. So it will reconcile every 5 minutes to basically ensure that Flux CD is always in the correct state. And then Flux CD will ensure that everything else is in a correct state, right? So that way, without a lot of hands-on, you're able to kind of deploy everything and manage everything and heal everything. Now, this is how the folder structure looks like in the GitHub repository that I mentioned, right? The Bootstrap repo. This is how the repository structure looks like. I've expanded only for AWS because we run a lot of things, right? So this is how it looks like. You have files for AWS, Azure, GCP, and common, right? Things that are common. So for example, Kube Prometheus stack doesn't depend on any specific cluster, or not Carpenter, actually, I forgot. VM agent, for example, yeah, VM agent. So these are some of the common things, and certain alerting. So for example, API server alerting, configuration, all of those reside in the common folder. And if it's, let's say, an AWS cluster that we're bootstrapping, then the root customization that I was talking about will point to the AWS root customization.yaml. So here, right? It'll point to here. And this customization file will point to all of the customization file. For anyone who has already worked with customization will know how that templating works, right? You reference files which needs to be templated. And it will refer to all of these customization as well as the common, so that all of these get applied to Flux CD as to the cluster as a declarative configuration to the API server, and the Flux CD will keep a watch on these objects, and it will automatically go ahead and apply this, right? So this is how we kind of ensure that, and let's say we want to make a change just for AWS. We just make a change to that folder, and it will automatically get picked up across all the clusters and for any new clusters that we create, right? And then you can have things like Canary and stuff, which is a part of Flux CD, which we already do, and you can do a lot of Git flow mechanism, PR reviews, and all that stuff, right? Do a lot of things in CI to ensure that the config that gets pushed here is always fine, right? And then we have a Git flow that we have configured where dev, staging, and prod have long-lived branches, right? So we don't promote changes across environments, we promote changes in stages. So yeah, that was my talk. And yeah, we are hiring, so please check out open positions here. We desperately need to kind of scale this infrastructure. Thank you so much. Appreciate it.